Right. In this class, we're going to go over Nuke Gizmo that allows us to apply a directional blur for our images. And we're going to learn how to create this directional blur effect from scratch. Um, we're going to be using assets that we made available on the Patreon uh, in this class. Um, the shot is called Prettier and Better. You can see it playing over here. And I'll be providing the images for folks to follow along with the class. So it's just going to be two still images, one for the character, one for the environment. The animation for this shot was created by Ozan Bazaldi, and it has been made available to us by Frame by Frame. So I thank Liron for making this shot available to us. All right. Um, so at the bottom of the class, you'll find the images you need to follow along. And let's get started. Right. So the directional blur is a really important effect to learn how to create. Not just for like the most simple application, it can look like maybe you're in some kind of altered state of mind. But mostly what we're interested in is the application for any kind of optical effect. Like in this case, you can see these glints. Uh, those can be made using this effect. And of course, lens flares, uh, anamorphic lens flares, anamorphic glows. All of these type of opticals um, use directional blur for its building block. So it's very important to learn it. And there's even more applications because essentially to create a directional blur, in this case, we are taking the image and we are rotating it before we apply a blur on either of the axes, either on the horizontal axis or vertical axis. But because we're applying it while the image is at an angle, once we flip the image back to where it was, now we were able to apply this blur at a specific angle that we can decide. So essentially, this class is both important because we show how to create this effect, but it's also important that we show this technique because it can be used both in 2D and 3D to essentially apply complex transformations by simply rotating the data rather than trying to apply the transformation on our effect. So it's a really important class, and the gizmo itself is very, very simple, um, but it's the principle that is really important, and that's why I'm making this class. So in order to follow along, you'll need to have Cryptomat installed. If you have Nuke 13 and above, then you can just skip. But essentially here we learn how to download it and install it so that you end up with Cryptomat available here. Then I show how to bring in the images, how to set them up with an over node, and then, drop a new Cryptomat node, select the window to generate a map out of it, and then how to take the beauty and mask it by the map of the window so we can isolate it. And then, uh, for the purpose of the class, I'm simply just making it bright overall, but I'm cheating a little bit. I'm actually bringing some gizmos from other classes that are more advanced, specifically the pigred, um, and I'm using it to draw some 3D gradients based on the world position, so that we can isolate just the top of the window. If you have not seen a pigred before, it might feel like magic, but it essentially allows you to create 3D gradients that stick in world space. So it can be very useful to shape assets. It can be very useful to create gradients in 3D space. It's one of the most important tools to art direct an image you can use in Nuke. So that's what I'm using here. You can just follow along using a radial if you'd like, but I use a pigrid. So this is what the node graph looks like here. You can see I have a bunch of pigrids just to create this very specific roll of like fall off for the way that the gradient behaves. So anyway, we finally get to the good stuff, which is we apply a blur node. And by default, you can see the blur node just applies the blur evenly across both the X and the Y, which gives us this sort of glowy look. Nothing special there. What we never explored before is that you can actually split the width and height. So you can change it. So now you get this blur only across one angle. But seemingly, we should be able to only apply either vertically or horizontally because we don't have any rotation control on it. So uh, this is where it gets interesting because we can apply a transform before, set it to a rotation of, let's say, 45, and then a transform after with the opposite of the rotation. And voila, now we can rotate our effect. So now here we get into the actual um, um, instructions on how to create a gizmo. So we start adding knobs so that we don't have to always type rotation and then the opposite by hand. We can simply create a knob called angle, and then we adjust the two transform nodes to point to that knob. One of them will look at that knob directly, the other one will multiply by -1, which you can do using this minus in the expression. And then we also want to make the size of the directional blur available to the user through a knob, so we don't have to create that. So the user can adjust the size of the directional blur from the gizmo without having to dive inside. And then this is also something really important that we learn how to do. We learn how to set up some expressions that allow us to um, switch the directional blur from the look that we just achieved to a regular blur. So we can essentially decide the intensity of the directionality. So at 1, it looks like a directional blur. At 0, it looks like a regular blur. So essentially you can achieve this type of look where maybe the directional blur gives you too much high frequency detail and you want to smooth it a little bit, but you don't want to go back to the circular sort of uniform blur. So we learn how to set up a logic that takes care of that. And I go into detail over why this logic works the way it does. And then finally, we do some little changes on the inside of the gizmo. We expose what channels are going to be affected by the gizmo. Because by default, it will try to apply the blur to all of them. And that's 99% of the time not what you want. Because this would like destroy data IRBs, it would destroy crypto map data. So the vast majority of the time, we just want to operate on the RGBA. So we're exposing this, and then we're changing the default so that next time we drop it, it will just default to RGBA. Then next thing we take care of is the size of the bounding box, because anytime you apply rotation on the whole image or blur, the bounding box will tend to shift, and it tends to only grow bigger. It's very rare your bounding box will get smaller. So as you stack multiple operations, eventually your bounding box gets out of hand. So we try to bring it back to the original, and we use an expression uh, that grabs the resolution of the input image. So this should work on any project, regardless of the resolution of your shot. And so you see that now the bounding box is fixed. It's much smaller. Then we adjust some small stuff like those transform nodes we dropped. By default, their center is hard coded, so we use an expression to again drive that center dynamically using the resolution of the input image. And then we just give a name to the gizmo and give it a unique color, and that's it. So you can see if I jump into Nuke here, this is the live gizmo. you can see that I can interactively make it smaller, I can make it bigger, and I can interactively rotate it as well. So it's a very, very simple gizmo. It literally only has a couple of knobs. Um, but we're going to be using these principles shown in the video over and over the next few classes, over the course of more complex classes. So it's very important that we have a class where we go over them. Uh, so this concludes the class. I hope that you enjoy it. And if you enjoyed, consider subscribing to the Patreon so you can support um, the creation of more classes like this one and the creation of more videos. So thank you so much and have a good one.